now into the boring stuff. So, what are containers? In order to understand containers, I'm really quickly going to talk about what the differences are between like traditional virtualization, so like your virtual machines. More people need to know. So, what a virtual machine is it uses something called a hypervisor, and it emulates your computer kernel and all the hardware and all the software, your operating system, the whole shebang. So it's an entirely like software-based computer on your computer. Obviously, problems with that, it's chunky, it's slow.
Have fun.
Is that better?
Yeah, but you have to speak directly in the microphone.
Okay, I will try. Does anyone call anything I've said so far?
Yeah.
Okay, right, perfect. So, containers try to solve some of these problems. So they don't actually, traditionally, they don't have a hypervisor. So they only emulate all the software, so they have to be obviously compatible with whatever machine you're running it on. This makes them much more lightweight, so you can get a lot more containers in the space that you'd only get one VM. And it also makes them a lot more portable, which obviously is good if you're trying to like ship out lots of containers to people. You don't want having to wait ages for the setup and this, that, and the other. Although the problem with this is they're not fully isolated as a result, so you have to watch. Breakouts are a lot easier, so you have to be careful and watch your security on them. So, Docker. Created in 2013, currently uses Containerd as its runtime. When people talk about Docker, they're usually talking about like Docker Engine or Docker Desktop, but Docker has tons of products that make up. These are just some of them, there are others. So real quick, Hub, this is an image repository, that's all containers built of images. So that's where you get them. You get official and unofficial images. So official ones, Ubuntu, Apache, all that. And unofficial, anyone can make images and upload them, so it's got an account. Docker Engine, that's just CLI. So that's what I'm mainly talking about today. Yep, that's what I'm mainly talking about today. Using Linux, and that's how you create, run, manage everything. Docker. Docker Desktop is essentially a GUI version that you use for Windows. And then, yeah, Docker containers in Windows are a whole separate kettle of fish. It's got Hypervisor, Hyper-V, or WSL2. We're not getting into that. Compose, which is YAML files, so if you're wanting to create lots and lots and lots of containers, or you've got a very specific setup that you have, you chuck it in like a nice YAML file so you can like spin it up whenever you want. And then Docker Swarm. Have you ever heard of Kubernetes? It's just a container orchestration solution. So Swarm is Docker's version of Kubernetes. So it just lets you manage hundreds of containers at once. It just makes it a little bit easier for you. So, vulnerabilities. What's wrong with containers? I went on the Mairi database, and literally like 2 days ago, 194 CVE records for Docker alone. So there is a lot. There's a lot out there. Some, I'm just going to go into some, I'm not going to go into all, because we'd be here all day. Some, like, vulnerabilities and misconfigurations, mainly. I will say, however, not judging anyone if you're running containers like this. Obviously, Docker wouldn't let you do it. It wasn't the purpose, so there are reasons why people run their containers like this. It's not like a gotcha moment. You see someone running their containers root. They're probably just using it to debug. You can also use the privilege flag. Not always a great idea, because one thing with containers, like I said previously, they're not fully isolated. So even if you're not running them as a super user, if you have root access inside that container and you break out, you then get root access on the host. So, very dangerous to run this root. Adding extra capabilities and not restricting resources sort of goes without saying. You can use that to like damage the host machine or any applications in the container, DOS attacks, the whole... Oh, how can I say? I can't see that. I'm sorry, well, this is my work computer, and it's having a day. There we go. Nope. This talk's just going great. Right. Dangerous directories. So sometimes you need some files, resources, applications that are on your host machine. You can mount them into the container. Absolutely fine, not an issue. But there are certain directories you probably don't want to be allowing your container to have access to, etc, bin, home sometimes even, you've got like SSH keys. So just be mindful of that. I did say I won't judge, but if I see anyone mounting your whole host file system to your container, I will find you. That's unacceptable. What is the point of using containers at that point? But it is something you can do. I don't know why you would. And then running containers in the host namespace. So, talk about namespaces in a second, but essentially, namespaces restrict what processes can see. And you've got a host namespace, and if you tell a container just to mount onto that, you can see all the processes on your host, and then you can mess about with them, which is not a good thing. And that's the flag if you want to do it. PID process. So, more. Unofficial images. Like I said, anyone can upload images. It's a bit of a tricky game. Some companies make their own versions of images. If they've got very specific requirements, it's fine. But just be mindful of what you're pulling. So, some research was done in 2020, and they scanned all the images in Docker Hub, and of the unofficial ones, 74% of them had medium and high rated vulnerabilities, compared to only 47% of the official ones. So, also in 2019, a security research company found multiple containers that have cryptocurrency mining malware on it, and Trojans and all sorts, and one of them in particular had 2 million pulls. So there are containers out there that are mining Bitcoin and people don't even know. Not regularly updating your images, so it's really easy to spin up a container, have it do something small, and you just leave it, you ignore it, you don't think about it, but you need to update it. It's not difficult, please do, but you need to be careful. Docker can be a bit funny, so it's easy just to be like, update late, I'll just pull the latest image. Even unofficial, they forever are releasing unstable images, so you can actually give yourself more vulnerabilities than you initially had. So always try and go for the latest stable versions. For example, in 2020, there were 40 CVEs for Docker. 32 of them had the exact same vulnerability. All of them were given a CVSS score of 10 for privilege escalation. Every single one of them, the root user password was blank. So, again, be very careful about what images you're pulling. Like I said, poisoned images, people are forever putting malware and things. And networking. I'm not going to go super into networking, but if you're exposing your container to the internet, be really careful. There's currently an APT called Team TNT. Sounds like a Minecraft server, and if you Google it, that's what's going to come up. They're not. And they essentially scour things like Showdown, and they're pretty indiscriminate. Their main motivation is finance, so even if you're just Joe Blogs, they're going to try and put cryptocurrency mining malware on your thing, and they don't care. And if you want to know more about their attacks, you just say something factually incorrect about them on Twitter and they'll correct you. Right, so, is it all doom and gloom? What can you do? I have the solution. Well, solutions, some of them. I will also say, none of these have to be used separately. You can mix and match and combine a whole bunch of them. So, namespaces, I did talk a little bit about them. You can't really see last time. So, yeah, they restrict what resources a process and its children can see. I have some people refer to it as almost like a container light. So it's not a container at all, but so essentially you put the process in a little bubble where it doesn't know it's being restricted, but it can't see what it's not allowed to see. So it thinks whatever it's seeing, that's it. Docker remap. Yes, so Docker has a default namespace that you can enable called Docker remap. And that first file path, you just create daemon.json, and then you add in essentially just user ns remap default, and you're just please use the default namespace, and it will. And those bottom two are just where you check seeing namespaces if this is enabled. And it's a pretty good one. It's not too restrictive, but it just stops little minor things. CGroups, control groups. Very similar to namespaces, but the process knows it's being restricted. unlike namespaces where it can't see, CGroups knows. And CGroups are specifically for hardware resources, so like memory, RAM, CPU, all that shenanigans. So really useful if you want to try and prevent like DOS attacks and things like that. Again, it's screenshot, but I just did I restricted memory and swap memory, and honestly it's like 3 lines of code. Really easy to do, would recommend. Right, getting into slightly more complicated. So AppArmor. It is the default Linux security module used by Docker. What is a Linux security module? Well, as the name suggests, it's a way of securing processes and applications in Linux. And you get 2 types. You get mandatory access controls and discretionary access controls. So DAC, or discretionary access control systems, are like the older ones. And they put all the users into groups, and they restrict the users from accessing them. So like group 1 can see ABC, group 2 can see ABF. But the problem is, it doesn't restrict the processes that the users are running. So a user can just run a process and be like, right, now go talk to like C, and they can see it. So they came up with mandatory access controls, which are a little bit more modern, but again, they're pretty old still. And they are a lot stricter, and they restrict processes rather than just like user groups, so the processes themselves can access things. AppArmor itself is policy-based, so you set up little policies for you're running. Docker has one called Docker Default that you can set up. It's a bit funky, you can't really edit it, and it sort of like disappears from your file system. I don't know how to touch it, and I don't want you to touch it. If you want to create your own, don't do it by hand. Don't. It's horrible, it's disgusting, no one does. Here are some nice command line tools you can use. EasyProf, Bane, and my personal favourite, mainly because of the name, is SecureBully, and that's the one specifically for Docker. The other 2 are less specific. But they're really easy, just a couple lines of code. You just tell them what containers you're running, what sort of things you're going to be doing it in, and they'll set up a nice wee AppArmor profile for you. SELinux. The bane of my existence, if I'm going to be honest. It stands for Security Enhanced Linux, and it's also a Mac system. But it uses labels to control access, so like all your files, all your processes, everything's labeled. That sounds great, and it is genuinely more secure than AppArmor, but it's absolute faff to set. Like, it's disgusting. I would say, unless you've got very sensitive stuff, or you're like working for a business or whatever, I wouldn't bother with SELinux. I'd just stick with AppArmor. Like, if it's just you doing stuff, small application at home, just like hobby or something, I wouldn't bother. But the reason SELinux is better than AppArmor is mainly because the logo's it's a penny with sunglasses, but also, so AppArmor only restricts Docker, whereas it doesn't restrict individual containers, so they're all got the same rule. Whereas SELinux, you can make specific rules for each container. So if they need different amounts of access, you can do that. And it's great. And it's a lot more difficult to break out of the rules and stuff on it. So yeah. Oh, Seccomp. Secure computing. It is not an LSN. It's not a Linux security module. But it's a kernel security thing. And it limits system calls that processes can make. Docker has a default one. It disables about 44 of your system calls. And I'm honestly, I wouldn't mess about with this too much. The Docker default one's pretty good. Here are some of the ones it disables. So you've got ACCT or account, and you can use it to disable resource limits. Delete module, you can delete kernel modules. Obviously not a good idea. Ptrace. So Ptrace, you can use to circumvent Seccomp completely. And the reason I have this GIF is because even if you have a Seccomp profile that restricts that you can't do a single system call, you can still run containers and just be like, oh, they'll let me do this system call. So if you're running a container and you can't do anything, but you've got Ptrace enabled, then there's no problem. An attack can just change everything and get out of those rules. So, I've sped through this. Right, conclusions. be careful of what you're doing with your containers. Make sure you're mindful of why you're what are you running them to do. So do you need all those resources? Do you need that file system mounted? New best friends. I would honestly recommend AppArmor, SELinux, Namespaces, CGroups. Try and set them all up, have a play with them. If you get Seccomp, not SELinux. If you get SELinux working, please teach me. I would love to know. I've never successfully done it. But yeah, I honestly wouldn't bother for day-to-day stuff, but give it a go if you want. Sorry for the disaster that's been me talking, but any questions? Also, I have a cat. If you want to see my cat? That's my Twitter. That's all I post. Yeah.
So the containers, so things like Docker, default instructions tell you to map on the socket. All of those things that talk about malicious images, are there any tools you're aware of to run, say, if they've been given Dave's container image with that goal, Dave's malicious script, and the command is driven with that, people don't know what they're doing. They just run that, for instance, where they ask those run with these inheritance to back up and say, maybe check that's good.
Oh, so are there any tools that will tell you if you're potentially running a harmful container? Yeah, I'm sure there are. I've not looked into that specifically, but I'm sure there are. I know Securability that I was talking about earlier, it does tell you if you're trying to run a container that it restricts, so that might be something similar. So it's you said you don't want this done, so why are you running it? Yeah. Yep.
Containers suitable for testing though, to know if they've got sort of an actual procedure, would it be aware of it?
So are containers suitable for running malware? Testing malware, sorry. I'd probably stick to VMs for that, because like I said, so my whole dissertation was container breakouts, and it's shockingly easy. So you're honestly putting your whole thing at risk doing that. But if you've got it, I don't know, even if you've got it super locked down, I wouldn't trust it.
It takes forever to
Yeah.
Take a minute.
Maybe. Let me know how it goes. But honestly, I would stick to a VM for that. Yeah.
So based on that, if you were to use containers to create honeypots, for example, services to be honeypots, is it different to do it with VM control? Because there's a way to just pop out of the container and actually expose the system itself, right?
So, are you asking if I would use containers as honeypots or VMs?
Yeah, or VMs.
I don't know too much about honeypots. I mean, if you want people to go for it, I guess containers are more attractive because they're lighter, and people don't have to install as much because VMs are massive. Yeah, I don't know. That's a good question. I don't have an answer for that. I'm afraid. Yeah.
I was going to say, on the malware and container stick, Docker's probably not the best container platform for that anyway, because they're meant to be lightweight application containers that don't contain things like a Linux system, or a web browser or anything else that malware would try to have to. You're better off going for something like an LXC container or a system container. But even then, the security concerns is still container virtualization. I hope that you were good.
Anyone else? No? Oh, thank you.